But yeah, thanks a lot for having me. I'm really excited to be here. My name's Chris, and tonight I'm gonna do a short talk on Meadows Retrospective. Uh, as I'm kind of giving the talk, I have Twitch up too. So if you have questions at all, feel free to just like shoot them in there, and I'll kind of watch as I'm going along and answer anything I can. But just a quick note about myself. As I said, my name is Chris. I'm a software engineer at Lunatech here in the Netherlands. We have offices in the Netherlands, just outside of Paris, and then also a new one in Brussels as well. I'm a big NeoVim fan. As Salar was saying, how he can now use Vim with Metals. That makes me extremely happy because, yeah, I'm also a Vim user. I enjoy working on tooling. I'm one of the current Metals maintainers, and I'm also the author of, as I said, the two Vim extensions. Just to double check too that my screen is actually being broadcasted to Twitch, because I have Twitch up and I don't see my screen. So I just want to make sure other people see my screen, if that's accurate.
Yes, I see your screen on Twitch.
I don't know why I don't see it, so never mind.
All good.
All good. All right, so what's the plan for tonight? So the plan is I'm just going to do a short intro. I'll do an overview of Metals in 2020, go over like a lot of the things that we added. We'll look at the year-end survey results that we sent out at the end of the year. We'll talk a bit about some of the common frustrations that people have with Metals. We'll go over some of the most commonly asked for features. Then depending on like how much time we have left, we'll go over a little bit of extra stuff, maybe do a demo of some sorts if anybody has like questions about how do you do something with Metals or does this work? And then also we'll answer some questions. So first of all, what is Metals? If you can, in the chat, just like say I use Metals, because I'm curious out of the 50 some people that are here, if there is like a large chunk of you that use Metals or not. But Metals is a Scala language server with rich IDE features. So that's a little like vague, but basically what it means is it provides you language features like autocomplete, go to definition, find all references, and all of the types of things that you would expect an editor to provide for you as you're editing. It works with any editor that knows LSP. LSP stands for Language Server Protocol, if you're not familiar with it. And I say more or less here because Metals makes pretty heavy usage of LSP extensions. So like any editor that supports LSP will work fine with Metals. It just may not have all of the extra like functionality that Metals can offer versus like an extension that's made specifically for Metals. And a question that I've seen recently a couple times pop up is, well, where does the name come from? And the name is just Scala Meta, which we use really heavily, language server Metals. And a retrospective. So what does that mean? So at the end of the year, last year, we decided, hey, this last year, we feel we like gained a lot of users. We've seen like an increase in downloads and engagement and stuff. So we really wanted to get a better picture of like where people were at with Metals, what they thought, what they wanted to work on, what they wanted us to work on and stuff like that. So we gave a year-end survey, which gave like a ton of useful information. So that's what I mean by retrospective here. And I also want to give a shout out to a few other people that like made Metals what Metals is. Plus, there's obviously more than I have here on the screen. But Tomic from Virtuous Labs on the far left-hand side is kind of leading the charge now on Metals development. He works full-time for the Scala Center and with Virtuous Labs. And yeah, he's sort of the one like leading the charge and helping everybody else contribute to it. Oliver and Gabriella are both two people that sort of laid the foundation of what Metals is, and they are still around and definitely help us out with questions and everything else too. And there's obviously like way more people than that have made Metals what Metals is. So a look at 2020. Some quick stats. We had 171,000 downloads in Metals last year, which doesn't tell a lot in itself, to be honest, because those are just like pure raw downloads. Doesn't say like how many were unique or per version or something. But I thought it was a fun stat to have. We had just over 100,000 VS Code extension downloads. That was our like most popular one. The second most popular one behind the VS Code extension was the COC Metals extension, which had just over 20,000 downloads. We merged in just under 700 PRs last year. We had 13 different releases, 46 contributors, and 54,000 unique visitors to the Metals website. So what are some things that we added this last year to Metals? I mentioned LSP before, and LSP, the language server protocol, defines a whole bunch of different methods that you can implement, or that every language server and client should kind of implement. And it was actually kind of crazy looking through some of these, because I didn't realize that before last year we didn't have some of the stuff that I'll go over. So it's pretty cool to see everything that was added. So things like text document implementations, where you can find the implementation of any symbol or member all throughout your code base. We didn't have that. Text document renames, which allow you to rename symbols. We didn't have any foundation for code actions at all. And this last year, we added both just in general the ability to do code actions, but also the ability to import missing symbols, insert missing abstract members, create new symbols, import all missing symbols, organize imports, and insert inferred type refactorings, and organize imports. I put that one in there twice, maybe because I'm excited about it, or because I didn't realize I put it in there twice. We added debugging into Metals this last year. This is one that often gets talked about in VS Code, but it actually is in multiple other editors as well. So VS Code supports it, NeoVim supports it, and Emacs supports it as well. And I'm seeing some questions come in too. So let me finish this section and I'll go to them. And I do have an image of VS Code here, and I purposely put VS Code as the example for debugging because I wanted to talk about this a little bit later. So remember that I talked about debugging and that I put a picture of VS Code. We implemented worksheets, which are one of my most favorite features probably that I use super often. They're actually implemented with MDoc, if you're familiar with it, which a lot of people use to parse or to type check Markdown and to make like a Docusaurus website with it. It's another Scala meta project. But yeah, so it powers worksheets behind the scenes. And as you can see, it allows you to get real-time evaluations in your worksheet, and then allows you to sort of hover over the evaluation result and get the full result. And this works in almost any editor at all, that will, even editors that don't support virtual text. We added the ability to analyze stack traces. So you can just copy a stack trace, do the Metals analyze stack trace command, and you'll get like a nice web view of the stack trace where you could just click and jump to the part of your code base where the stack trace is from. We added tons of stuff to do with synthetics. So things like show implicits and type decorations, show implicit conversions in classes, type decorations for definitions. And you can kind of see that in the example I gave here with the VS Code, where you see all the inferred types that are shown there. And that's not actual text, but that's virtual text that is being inferred. And I purposely used VS Code here again, even though I'm a Vim user, because I'll talk about it in a little bit in the future here. And we also added a ton of other features that honestly each could have like its own slide, but just to name them all, is we have a new file provider, which will give you like a new class, object, case class, or whatever type of file you're trying to create. We have a rename preview. So if you do a rename and that touches like a whole bunch of different files, it will actually in VS Code pop up and show you like a preview of all the files that it's about to change. Super method code lenses, which are turned off by default actually, but once you turn them on, you'll see virtual text next to like a method, and you'll be able to jump to the super method and the parent methods of that method. Ammonite support, Alex Archambault actually like jumped in and just like dropped Ammonite support into Metals, which was an awesome feature. A new project provider using Gitter 8, so you can bootstrap an entire new project with like 2 clicks basically while you're in Metals. Multiple build tool selection within a workspace, meaning that if you have a project that has, for example, like a build SB SPT and a build.sc if you're using mill, you can open that up in Metals and it will actually give you the choice. Are you trying to use SPT here or are you trying to use mill here? And it will like intelligently know that. There's also SPT file support for things like completions, hover, and stuff like that. But it's not as advanced as the rest of the support we offer in Metals, but there is basic SPT file support if you're using Bloop as a BSP server at the moment, not SPT, ironically. Customizable package exclusion. So like if you're a Scala developer, but you don't want like Java DSL, Akka stuff, you can exclude those. We added in SPT BSP support, which was really exciting, and then also remote debugging, which is pretty self-explanatory. So like there's a ton of stuff that we added this last year, and like I said, as I was going through this list, I was like, "What? Like I can't believe we didn't have this like before last year," which is crazy to see how much we added. So I'm going to jump into some of the questions that came up so far. So one of them wasn't the point of LSP not to have an implementation of separate extensions for each editor? Why VS Code and CC need different implementation for Metals? Cool. So that's a good question. I kind of clarify what I meant by that. So what I meant by that was LSP does provide like a base protocol for any editor and any language server that can follow. But then certain editors, obviously, as you can think, because of different languages, there's very specific things they may need. So in Metals, some of the things that we've needed to implement, you just really couldn't do it with the base LSP support. So then on top of LSP, you create an LSP extension, which then defines the protocol of that extra thing that you're trying to do. So then the specific extension will be the one to implement that LSP extension. So there's like lots of extensions going on, but that and enables and sort of unlocks extra features. So like the tree view protocol is one where like in VS Code on the left-hand side, you see like a full tree view, or any editor. Emacs supports it, Vim supports it as well. And I think your question was actually a little bit more towards like, why do you need specific editor implementations instead of just using the editor itself? And primarily is because you could, for example, like I'll use the COC example because I'm more familiar with it. So COC, why does it need a separate implementation for Metals? Because you can use COC. For those of you that aren't Vim users, COC is like a LSP extension to make Vim speak LSP. And you could use Metals with COC without an extension, but you're just going to get very basic support. You're not going to get automated, you're not going to get automated installation. You're not going to get any of the LSP extensions, the extra ones that Metals needs. And you're not going to get, it's not going to know, we use something called execute command a lot. Like I want to do a build import. So if you don't have an extension that has build import button into it, you would have to somehow like type out, execute this command. Here's the name of the command, send this to the server. So it does a lot of stuff like that. Okay, cool. So I'll jump on a little bit. The next thing I'll talk about is the survey results. So again, if you took the survey, thank you. It was super useful to get insight from different people. One of the first things that we asked was, how important is Metal support to you in the following editor? And surprising to like literally nobody, VS Code is wildly more popular than any editor, as you can see here, with probably Vim being the second most popular, and then Emacs, Sublime Text, Eclipse, and then Atom had like no support here. And to be honest, this was like the last thread, I would say, for us to decide if we wanted to just drop Atom support completely. So actually, shortly after this, we dropped Atom support. But here it kind of shows you the breakdown of Metals users and what editors they're using. And one question that came up like throughout the survey in multiple different places was, why is there so much focus on VS Code? And that's a good question, but also like a question that frustrated me a little bit, because I was like, oh, it's not the truth. The short answer is there's not like so much focus on VS Code, and I'm going to give you a few examples of that, because a lot of the examples we get, or a lot of the examples people give to say like, oh, this killer feature is in VS Code, but it's not in other stuff. And one of those features is debugging, and actually there's other editors that work fine with debugging support in Metals. Emacs also works great with debugging support if you're using another extension, I think called DAP mode. This view that you're seeing on the screen right now is actually, it's showing something that's not actually merged into Metals yet. I was really hoping to have it merged, but it's not. And what it's doing is that this example is to show you that you can also do debugging in Vim and running and testing. And what this is doing actually is you're in a file that has multiple main methods, and you can just say Metals run. There's no configuration. You're not passing in any launch.json, anything, and it will automatically find the main methods in that build target and then give you the option of which one you want to choose. And the same thing for tests and tests in a single file. So you could just say test this file, and it will test this file automatically. Or you can say test this target, and it will test all the classes in that target that are test classes. And that's something that's currently being worked on. But debugging itself works in Vim, it works in Emacs, and it works in VS Code as well. Another thing is I mentioned a little bit earlier about the Analyze stack trace command, how it opens up this like really neat like web panel that you can click on. But there's some of us that don't like clicking on stuff because we don't want to use our mouse. So this is a really good example of COC metals of being able to use the Analyze stack trace command. And you don't have to use it like, you can use it in combination with Bloop CLI even. And that's what I'm doing here is on the right-hand side, I try running a project with Bloop CLI. It doesn't work. I have an exception. So I can literally copy that exception from the terminal and go into Metals, which is the left-hand side, and then hit the Analyze stack trace command, and it will read into that. And then it will, I don't have a web view, so it will actually give me another file, which is like a hidden file with code lenses on it. And I could use those code lenses to then jump to that part of the code base where the stuffing. So we've like made sure to implement these features in ways that work in editors that aren't VS Code, basically. Another big one is like all these implicits. Like we have these really cool features to toggle implicits on and off, or implicit conversions, or inferred types and stuff like this. And one of the first things we noticed, like when we were adding those features, were, oh, look, well, this doesn't work so well if my editor doesn't have virtual text. And not only does it have to have virtual text, but it has to have inline virtual text. And the amount of editors that have inline virtual text are like pretty few. So as you can see here, for example, it has an implicit parameter that it's showing in the bottom section of the hover called with synthetics added. And this will work for conversions, inferred types, implicit parameters, all that types of stuff. And they're all under settings. They're not turned on by default. So you can get all these features in editors that aren't VS Code. And I also want to take a moment and just say too that like from the very beginning of Metals, they did an amazing job of making sure all the features that were added in a way that were agnostic to editor. So you can truly like do the vast majority of stuff in Metals in any editor that's not VS Code. VS Code is like an amazing editor. So that's why a lot of people use it. And that's also why a lot of people have the assumption that like all the stuff we're editing is for VS Code, when in reality, it's really not. And I also want to like take a moment and point out some of the extensions that we have. So we have a Metals VS Code extension. We have the COC Metals extension, which works for both Vim and NeoVim. That was the kind of the first Vim extension we had, but then I also made another Vim extension called NeoVim Metals. This one is targeting the next release of NeoVim, which actually has LSP support built into it. So COC Metals is, I would say, more stable and more featureful-ish, but it requires a whole other plugin to allow LSP to work inside Vim, where NeoVim will not need that. It'll by default have LSP built into it. So that's what this plugin is for. There's a Metals Sublime plugin, there's a Metals Eclipse plugin, and then there's also an Emacs LSP Metals plugin as well. So lots of editor extensions. And at the end, I actually have another slide about like why this is important as well, which will maybe get to the question that was asked a little earlier as well. The most common request we got in this part of the survey was, will you support IntelliJ? And the short answer is no, like we won't support IntelliJ. The longer answer is that Metals was never intended or created as an IntelliJ alternative. Like if you use IntelliJ is incredible. And in some ways, like IntelliJ is I dare I say, like far superior than Metals. Like if you're using a very intermixed Java and Scala project, like Metals will not offer you the same level of support that IntelliJ will. So the goal is not to convince people to move away from IntelliJ. The goal is more to provide an experience for people that already have an editor of choice and they may not want to use IntelliJ. So that's, or they want a lighter word alternative or something else. And that goes a little bit into this question that we asked in the survey was, why do you use Metals? It was actually like pretty mixed. So some people said I wanted to use my favorite editor, which this was me, for example. I wanted a lighter weight alternative to IDEs, or I wanted more accurate compile errors. That's another one we get, is like, I get little squigglies in places I don't want to get little squigglies. And we directly are getting diagnostics from the compiler. So like if it's running, you should be getting the same exact diagnostics from Metals. And then I wanted a fully open source solution was also pretty high up there. And as you can see, Metals has feature other IDEs don't, wasn't very popular just because, yeah, the other IDEs such as IntelliJ do offer a lot more support. I see a question about Scala 3, but I will skip it and get to it later because I have a specific section on Scala 3. I also see, like, imagine making an LSP client for an IDE. That's a good point. And there actually are IntelliJ plugins, I think, that implement LSP for IntelliJ. But yeah, it's a good question. Like, why? Because IntelliJ works really well. The other question we asked was build tools desired support. Like, what is the build tool that you wish we had support for? Not really surprising to us was Basil came out on top of this. There's a lot of people that want Basil support. Next to that was Fury, Pants, Seed, Ammonite, generic workspaces, and then Make. And I'll kind of break these down into a couple different sections. So the first one is Basil. We get the question all the time, like, when are you guys going to support Basil? That's a tricky one because if you are a little bit unfamiliar with how Metals actually works, is you have your editor, and I think I have a diagram in here somewhere. Yeah, right here. So I'm going to skip this. I don't know why I ordered them this way. This doesn't make a ton of sense. So just look at the diagram and ignore the top of the page. So you have your editor and you have a build definition, and that is communicating to your language server through LSP. Then you have your language server, and that's communicating to your build server through BSP. So by default, the way that this works is you have your editor, so let's say Vim. Then you have your build definition, which we're going to say is SPT, for example. And then there's LSP communication between that and Metals. Then there's BSP communication between Metals and Bloop, which is used by default. So going with Bloop in mind, then, well, does Bloop support Basil? And that's the first question. And the question is, at this moment, no, there is no Basil integration for Bloop. So the immediate roadblock that we hit with Metals is that we can't add Basil support because there's no Bloop support for it. If you look to the right-hand side of the screen, you'll see that there are a rules.scala Bloop integration that was drafted, and it's a huge PR and a ton of work. It just hasn't crossed the finish line. So it's sort of like stagnated in this, like, will there be Basil support for Bloop or Bloop support for Basil? And we don't really know. So at the moment, like, maybe that will happen, but we are sort of beholden to this other stuff. However, one thing that may be a little bit more exciting, in my opinion, is the Basil BSP support. And what this means is that instead of making sure that Bloop can support Basil builds, you could instead use Basil as a build server. So similarly, one of the things we added this year was SPT BSP support. And what does that mean? Well, that means that instead of using Bloop, you could use SPT as a build server as well, besides your build tool. And that's what this diagram is showing here with Basil BSP, which is actually a JetBrains project. You could have your editor, your build definition could be in Basil. Again, you're communicating through LSP from your editor to Metals. And then the BSP communication, instead of being from Metals to Bloop, which would have your Bloop definition or your build definition, from Basil. Instead, you would just, again, be talking to Basil, which would also be serving as your build server. So this could be another way that we could implement Basil support. But again, it's more of a, like, we haven't really had the time to dive into it. I don't want to speak for others, but, like, I don't know Basil well enough either to, like, really dive into the internals of how this would all work. So it's something that once we have time, we definitely want to dive into. It's just, yeah, it's more of a time issue than something else. The other most common desired support for build tools are Fury, which comes up a lot, which is ironic because like it's not stable yet. There's Seed, and then also generic workspace containing Bloop. I put these three together primarily because they're all actually similar in what would need to happen, because all of these rely on Bloop, basically. Because Fury, I believe when you're using Fury, you will also have a .bloop directory, which holds all of your Bloop files. Seed works in a similar way. You can use Seed, I believe, to generate a Bloop definition as well for all of your Bloop files. Or you could just have a generic workspace containing Bloop. If you're unfamiliar with what the .bloop directory contains, I won't go that much into it, but basically it will just have like a JSON file for every build target every build target. So like in SBT terms, you'll have like your build target configuration. So like you'll have root dash test, and then root dash like IT if you have IT enabled. Why doesn't this work with Metals right now? For the most part, a lot of the functionality we need will work if we just have a Bloop directory. However, the tricky part is that for your editor, it needs to send in a workspace root to Metals. And sometimes if you don't have a build file at the root, then it won't recognize that there's a correct root there, and it won't send in anything, which either won't even trigger Metals, or Metals will be like, I don't see any build file, so I'm just going to assume you're not in a Scala workspace. So there is a little bit of tweaking that we need as Fury becomes more like widely used, for example, since it is like the pretty high up on the list of people wanting support for it. We'll definitely work on that and figure out a way to correctly detect a Fury workspace. And if I'm not mistaken as well, John Pretty is working on a VS Code extension that actually like wraps around Metals and has Metals as a dependency, and like offers even more in-depth Fury support and stuff. So that will happen for sure. And for Seed and Bloop directories, that's something we can definitely work on if people want it, basically. The next thing I want to talk about is Metals frustrations. So another thing we tried to do is like really read through all the comments in the survey, and we had multiple questions that were open-ended about like, what is like the one thing that we could do to make Metals a better experience for you, or like, or just like any other comments you have for us. And a lot of times people's frustrations came out in those. So we tried to do our best to like, just find patterns in that. And we weren't really surprised by any of them, to be honest. So one of the things that people hate, I even hate this, is when you're coding in something and you like can't jump to a definition, or you can't find the references, or something's not working correctly, and you look in the logs and you see like file name doesn't work for, or like whatever you're trying to do doesn't work for your fault.scala. There can be many reasons for this error, and like as a developer, sometimes that's like the most frustrating type of message you can get, because you're like, cool, thanks. Like this tells me nothing really. But the problem is that there can be tons of reasons for why something's not working. So like this is an accurate message. However, we do know some of this stuff, and we do know more information than we're showing sometimes. So when something goes wrong, like for myself personally, I always say like, if something goes wrong, I want to know what went wrong. When my build import doesn't work, I want to know why it didn't work. Or if my worksheet isn't evaluating, why is this not evaluating? Oops. This is something we're currently working on, is that we're trying to make sure that when something isn't working inside of Metals, that we like forward the information up to the user in a way that is like presentable, because we obviously don't want to say like, oh, it doesn't work, here's the stack trace, or here's the error. Like we want to do it a little bit nicer than that. And just to give you like a couple examples that we've actually worked on recently, like for example, if you're doing Ammonite and you're in an Ammonite script, and for example, a lot of people also don't know that at the top of the Ammonite script, if you want, you can do like a comment, and you can put the Scala version there, and Metals will automatically detect that. Well, it's not actually Metals. We use another library, a library called Ammonite Runner, a project from Alex, and that will basically pull in that Scala version of Ammonite. And then you can also do the same thing with a specific Ammonite version. So one of the things that we did was, if that didn't work, we just sort of failed and your Ammonite scripts weren't imported. And it was like, well, why aren't my Ammonite support why isn't Ammonite support working? And we actually knew like there's a resolution error, so we couldn't download this version of Ammonite. So we just buried it in the past. So instead, now we show a nice message like, oh, this version of Ammonite with this Scala version isn't available. Try a different one. So things like that. And same thing with worksheets and imports in worksheets. So we're trying hard to locate parts of the Metals experience that we do know more information, but that aren't always floated up to the user. A couple of questions did pop up again. Which plugin do you use in NeoVim to debug code? It's a plugin called NeoVim DApp. If you're actually, I'll answer that question a little bit later because it's a more in-depth question than that, and I want to spend a little more time on it because there's two answers to it. Another thing that people talked a lot a bit about was stability. Like they want Metals to be maybe more stable. And I broke this into 3 different parts. The first one was memory usage. And I think thankfully we've like mostly addressed this one already because one of the issues was that Bloop was like eating up a ton of memory and we had a fix for that. And then also Metals was at times eating up a ton of memory. We had a memory leak, which was fixed. So for the most part, this should be fixed. If it's not fixed, please let us know and we'll continue to work on it. But that's something that we're definitely aware of, is that we want to make sure that Metals is as light as it can be, because when working correctly, like Metals is extremely light. Stable and clear BSP connections. What do I mean by that? And why do I put a question mark by clear? So I'll break this into 2 parts. First of all, stable. Like BSP in a lot of ways is like an abstraction that you don't necessarily need to even know about in Metals. Like it's there. You kind of just like start Metals and you expect it to work. You don't really need to know a lot about BSP. So we want that to be stable, obviously, so you don't have issues with it. And then I put clear because, again, like at certain times, it's sort of an abstraction that you don't necessarily need to know a lot about. So like we want it to be clear if you need to know about it, but also like hidden if you don't need to know anything about it, because then you don't need to like add the overhead of understanding it. So now that we have the ability to like jump to multiple different BSP servers, such as Bloop or such as SPT, we really want that information to be clear. Like, what build server am I using? How do I switch build servers? If one's not working, what's not working with it? And how do I switch again? We also really want smooth reloads to happen. So like if you are changing your build definition, you will get prompted that you need to reload it. And then if that doesn't work, well, why doesn't it work? One thing like is there, honestly, Bloop and SPT aren't the greatest at this. If you have something that you screw up your build definition and the BSP reload triggers, you don't always get like the best error message about what went wrong. You just get told that your import failed and you have to fix it. So we would like to really improve that. And then finally, better recoverable state. There's certain times where you're using Metals and something just like doesn't work. And like a lot of times people will just like RMRF Bloop Metals target, just blow everything away, and then we'll start again and try to like fix it. And honestly, like you should hardly ever have to do that. And we really want to try to get to a point where it's very rare that you do have to do that, because there is a lot of times where if Metals gets stuck into a state where it's where something's not working, a lot of times it's like a pretty simple thing, if you know what it is, to get it working again. And sometimes it's just as simple as like, well, there's a file over here that's not compiling correctly. So if it's not for compiling, which means you're not getting SemanticDB for something, which means you're not finding references for something and it's not working. So you don't need to blow everything away for that. You just need to fix the error. So we're trying to get better at like really pinpointing what the issue is when you're in a state that's not working, and how can you recover from it. I'm going to take a quick drink of water. Is everybody following? Any other questions or anything that you have so far about like things, common frustrations with Metals? If you have a frustration with Metals that I didn't mention at all, feel free to drop it in the chat and I'll read it and maybe add it to the list. So this next section was things that we pulled from the survey that we felt that people were sort of the mindset of like, this would be a killer feature if Metals had this. I want that Scala 3 goodness. Scala 3 is the hot stuff right now. Everybody's interested in Scala 3. People want like the best support for it, and they basically want like the same level of support that Metals has for the rest of stuff in Scala 3. So like people want better completions, they want auto imports, better signatures, they want to see inferred types like they can see with Scala 2 now. And the thing is that we had to redo a lot of stuff in Metals to add Scala 3 support. As you're probably fully aware, like the presentation compiler of Scala 2 and the presentation compiler of Scala 3, which we rely on, is completely different. So we couldn't just like take a feature that we had for Scala 2, drop it in Scala 3 land and expect it to work. It's almost like we had to like redo a ton of stuff. Part of the reason for that also was because stuff was changing so much, so frequently, that we didn't really have the Scala Meta parser completed yet. And if you're not familiar with Scala Meta, and I keep mentioning that because we use it really heavily, and it's like an incredible technology that there are multiple people behind that have done tons of work on it. And there's two parts of Scala Meta. And one of them that we use really often is the Scala Meta trees. And what this is just an AST representation of your code. And we use this quite a bit for a ton of different things. And because this parser wasn't necessarily completed for Scala 3, a lot of the things we may need Scala Meta for, or a lot of the things that in Metals that we needed support for Scala Meta to do advanced type of features, we didn't have it yet. So we were almost fully reliant on the Scala 3 presentation compiler to do all of these features, but then that gives you sort of a limited subset of features, or a limited subset of features that we didn't want to implement with this presentation compiler when we knew when Scala Meta would be released and we'd have trees and SemanticDB for that feature, that we would just use that for it. So we were sort of like beholden to the grammar finalizing and then being able to do that. One big question that we also get, and I saw somebody like early on, I think in the chat, mentioned that they were excited about this, that what about Java? Like, I want Java support. Like, and to be honest, like we'll never probably have the level of Java support in Metals that you can get in Intellij because it's not a Java language server. Like there is a Java language server. It works really well if you're using like pure Java projects. However, like a couple weeks ago, I know I mentioned Olaf before, and he's sort of a wizard and just like does an insane amount of work and always really incredible work. But he recently started working at SourceGraph, and one of the projects that he worked on was LSIF Java. And this project, I'm not super familiar with it, so I apologize if this is a little bit wrong. But SourceGraph also allows for like intelligent code information to like find references and to jump around a really large code base, all using these LSFI files. However, during the process of working on this, he was able to enable SemanticDB in Java sources. And if you're unfamiliar with SemanticDB, SemanticDB is this other Scala, the other part of Scala Meta, which we use really heavily. And as you can see here in this little like code snippet thing, I just took like a main.scala and I ran something called metac, which is a command line tool from Scala Meta, which will produce SemanticDB from a standalone Scala file. And then I use metap, which reads this into a readable format. So here's the output. And if you're using Metals, every single Scala file that you have in your project produces SemanticDB like this. So you can kind of get the idea of what's going on here because you have like what symbols are in this main file. So we have, object main extends app. So we know that this is sort of a main method here. We have method X, we have method Z, and then we have all of these different occurrences of other symbols all throughout this file. So as you can see, we use this for things like how do you find references across your project? How do you just do anything that you would need to do to find different things in your project? So we really heavily use this, and it's only for Scala files right now. So that's why, for example, you'll be able to be in a Scala file, jump to a Java source, but then when you try to jump to another source from that Java file, you just get blocked and it doesn't work. And that code navigation doesn't work because there's no SemanticDB that was produced for those sources because it's a Java source. However, now that there is the ability to produce SemanticDB for Java sources, that unlocks a whole bunch of things for us on the Metals end, because now if we have Java sources that can also be producing SemanticDB, code navigation between Java and Scala gets unlocked because we have the SemanticD representation of our code base. So that's something that's super exciting, and I'm hoping we're able to like really jump into that this year. Refactorings. People want new code actions. Like the thing that we get mentioned all the time, I have a little lower here, is like, I want to be able to extract stuff. Like I want to be able to extract this into this method over here, or I want to be able to inline this thing. I want better support to move files around and to like automatically update the name of the package, and all the imports get like changed to match. And there's a whole bunch of other stuff, but time. Like all these refactorings are totally great, and there's tons of opportunities for them. They just take a lot of time. Another thing we get a lot, that people want a lot, is multi-workspace support. So this is something, for example, that Eclipse did a really great job at in the past, of like, I have 3 projects, they all have their own build file, they're all separate. I want to like load all of them up, and I want Metals to like know about them, and I want to be able to navigate between them or do a refactoring that like impacts other projects. Where right now in Metals, you can't. Like we need a single workspace root. So like you can open my awesome project, my other project, or yet another project, but you can't necessarily open all 3 of them at the same time. Or you can't have like a mixed project with like a front end, back end, and the back end located here, and you want to like open the root in one place, so then Metals knows exactly where like it should work. Like it doesn't, that part doesn't work great. That is something we're aware of, and it's something we want to work on, but it's implementing something that we like don't have support for at the moment in Metals, and it also is like a pretty large refactoring to work with multiple workspaces. So it's something that's on our radar. Better support for non-compiling workspaces. This is probably also the other thing we get the most questions about. I don't have a lot of information, to be honest, on this one, because this is a really large problem. And because we are reliant on things like SemanticDB so heavily, at the moment, we're reliant on a source to be able to be compiled before it can produce SemanticDB. And if it can't be compiled, it can't produce SemanticDB, which means that we're limited in the types of things that we can do. So there are different ideas of how to get around this, but they're, again, ideas that would take a lot of work and would make pretty large refactorings possibly. So yeah, it's a combination of, we need somebody who knows things like SemanticDB well enough, and also somebody who's like willing to put into effort to do these things. And here are some extra thoughts and reactions, because I also realize that we're coming up on time here. We plan to do a V1 release this year. What does that mean? Nothing. It just means we're going to release V1 basically. It's exciting. Like we've added a ton of support this last year. Basically what it means is that this year we don't want to focus on adding a whole ton of features. We basically want to focus on adding Scala 3 support up to the level of what we have for Scala 2, and then solidifying the current support that we have, making sure things are stable, making sure things are clear, making sure installation works perfectly, making sure things like proxies, that's another thing I didn't really bring up, is like we get a lot of questions about like, I'm behind this proxy and it's not working correct. And as you know, like the JVM ecosystem is super fun, because like Corsair is doing it one way, and then SPT's got its way to do it, and Bloop's got another way to do it, and Metals is doing it. So like you have all these different ways of like figuring out how to like get Metals to work correctly behind a proxy. But that's something we're aware of, and we're also trying to work on. So the plan this year is to do a V1 release, have a big party about it. People will be happy. We'll probably do like some type of stream or something, answer questions for people. But the focus is on getting Scala 3 support and making sure Metals is stable. And a note about extensions, which is what somebody asked a little bit about earlier. Having a Metals specific extension for your editor makes a huge difference, because like bare bones, you get bare bones experience. Like you do get things like go to definition works, find references work, or maybe renames work. But anything extra is not going to work. There's not going to be an automatic way to import your build necessarily. There's not going to be a way to choose to do a cascade compile instead of a normal compile. Metals isn't going to be installed automatically. Like there's so many different things that like an extension can help with the Metals experience, especially because Metals does make pretty heavy uses of LSP extensions. They need to be implemented in the editor. Also automate stuff that can be automated. Like I said, there's some editors right now, if you are going to use Metals 4, you need to like manually use Corsair to install it. Like that is pretty easy, especially now that we have like a Metals executable in the main Corsair channel. So you can just do CS install Metals. Like that's super easy, but it'd be even better if you didn't have to do that. And then also things can be done in line with the editor. Like if you're a heavy Emacs user or Vim user, you know that you like really care about how your editor is set up. So you want to do it a very specific way in line with the editor. So all the extra things that you have around the Metals experience can be done in that way. So extensions are extremely important. And it's also a great way to contribute to the project, because those of you who are using an editor, maybe besides VS Code or VS Code, and you have like pain points with it, they're totally hackable and able to be edited and stuff. One other point I want to bring up is that there was a couple points in the survey where people seem to be concerned that like, you know, Scala ID is gone now. What happened? Is Metals going to be gone? Like, how do I know Metals is going to stick around? And I want to like assure people that Metals is not going anywhere. Like the Scala Center is very invested in Metals and is behind Metals. Virtus Lab is extremely invested in Metals. They have multiple people that are working full-time basically on Metals or on the Metals ecosystem, because there's a lot of other tools related there. My own company as well, where I work, Lunatech, is also like super gracious with their time and gives me sometimes multiple days a week to work on Metals. So like there's like both community support for Metals and then also like business support and Scala Center support for Metals. So like rest assured to know that like you're not going to wake up tomorrow and Metals is going to be like a dead project. Also, documentation helps. If you have something in Metals that isn't working great or that you're confused about, documentation always really, really helps. Like for us that are working on Metals all the time and are like diving into things, we very like quickly forget that like certain things that are extremely clear to us like are not clear to other people, or things that you know, how do I do this in Metals? And it's like, well, you just do this, this, and this, and like it's really clear. Like that's not clear to everybody, because if they've never done it before, it's not written anywhere necessarily. So please do help with documentation. Let us know if something's missing from the docs. We'll totally add them. We're also like very open and quick to respond on the various channels that we have. So please reach out to us if that's something that you think we could improve on. That's pretty much it. I feel like I went over like a ton of stuff. I hope that was informative. I hope you get a better idea of like all the stuff that was added in 2020. I hope you have a better idea of where we're headed this next year. And yeah, so let me look to see if there's any questions in here. So I'm glad to see the Scala Center's Google of Code. Yes. This comment was that the Scala Center has applied for the Google Summer of Code, and there's a large project list, and there's quite a few Metals projects that are listed on there, and one of them is added mixed Scala Java support for mixed Scala Java code bases. So that'd be super cool if that would happen. Scala Steward apparently has LSP support. Not really sure what that is. Let's check this out. Oh yeah, LSP support for Intellij. Yeah, so I'm pretty sure, like I said, there are some LSP support plugins for Intellij, but they're not like maintained by Intellij. They're just like community plugins. So we probably wouldn't. Yeah, I think I went over that pretty well enough that I don't have to do more. Question: which plugin do you use with NeoVim to debug code? Great question. So it depends on if you're using COC Metals or if you're using NeoVim Metals. If you're using COC Metals, there's integrated support for a plugin called VimSpector, which only works if you're using NeoVim with COC Metals. And VimSpector is a great project, and it offers support. If you look in the README, there's even a section about it. If you're using NeoVim Metals, then I'm working currently on an integration with a great Lua plugin called NeoVim DAP. And DAP stands for Debug Adapter Protocol, and it's what's needed in the client side in order to make debugging stuff work. How did the name of Metals come about? That was already answered. Hi, Chris. Emacs frustration question above. Thanks. Did I miss it? Oh, yeah. Just my Emacs LSP Metals Scala experience while just typing, burns CPU, introduces keystroke latency, laptop runs hot, had to switch off. Yeah, so without knowing more information, I don't have a whole lot to help you with probably, but I would say things to look at. yeah, jump on something like top and see like what's actually eating up all the memory. Is it Bloop that's running in the background that's eating it up? Is it Metals that's running and is eating it up? And if it is Metals, then please let us know. If it's Bloop, let them know. If it ends up being like LSP mode or something for some reason, then yeah, you kind of have to like figure out which part of the chain is causing the memory issues. So yeah. Regarding Scala IDE. Yeah, exactly. So Eclipse, if you saw on the chart that we had, like the Eclipse usage is extremely low. So if you have a project like Scala IDE that's really tied to an editor, it's really hard to maintain a project like that if you have a very small amount of users. Like honestly, it's just not worth it. And that's one of the things that LSP kind of aims to address is that there's wider range of support because there's every editor that supports LSP can use it. So yeah, it's a really good point. That wasn't like a jab at Scala IDE or anything at all. Like great project. So any other questions that people have or anything? Question, is the new feature you showed for run test, will it replace Vim test? I don't know what Vim test is actually. Is Vim test a plugin specific for Metals, or is it a plugin that's agnostic to like the language server? Vim test, run your tests at the speed of. I'll say yes, it'll replace this for me anyways, or yeah, because I think, so this is like my 10-second look at this to understand what it probably is. I'm pretty sure that these are actually just using SBT and Bloop directly to run these tests, which are totally fine. Whereas if you're using something in like NeoVim DApp, for example, you have the full debug adapter protocol at your disposal. So where you can use this, for example, to just run a test and get the results. What I didn't show was that you can also set breakpoints and step in and step over and all that type of stuff with something like NeoVim DApp as well, where with a project like this, you wouldn't necessarily be able to do that. So this is probably great if you're just going to run or test, but probably not great if you want to do more in-depth like debugging and stuff like that. It's a good question. Anything else?
Thank you so much, Chris, for awesome talk and coming to SF Scala to give the talk. Selfishly, I really appreciate all your work on Metals and Vim integration. So thank you so much.
Yeah, it makes me happy to hear when people are using using it.
Yeah. I remember setting up Metals before the COC Metals plugin, and it was like a little annoying to have to self-configure it and download the executable, put it in your path, and
yeah,
there's a lot of ceremony involved that I don't have to do thanks to your work. So super appreciate that. Thank you.
Yeah. One thing that's really cool is like, for example, in COC Metals, like something that I think maybe isn't clear, and this is the same with VS Code as well, is that when you actually start up Metals through VS Code or through COC Metals, you're not actually starting an executable necessarily. We're using Corsair to like grab the full class path of everything that it needs to run Metals and to start it. So you can actually like be working on Metals and do a publish local and just restart VS Code and you automatically have like the new version of Metals that was published there. You don't even have to like click install or do anything. It's pretty cool.
That's awesome. On that topic, I would love if we could have a speaker do a talk on Corsair more. I don't think there's enough online content on Corsair, and it's like a unsung hero to many of us.
Yeah.
If you know anyone in the Scala Center who I can tap for doing a talk on Corsair at some point, let me know.
Really, I mean, you can always maybe ask Alex if he's willing to do it himself, since he's the wizard of Corsair. But I also know that the Scala Center, in collaboration with 47 Degrees and with us at Lunatech, one of my colleagues, Eric, who's our CTO in the Belgian office, actually just did a video on how to set up Scala, your full like in Scala environment using Corsair, and that video I think just aired like yesterday or 2 days ago. So it's a cool video to check out, and I believe they have more videos upcoming as well. Yeah.
Awesome. That's great. Fabulous.
Yep.
Great. Thank you both, William and Chris, for coming to today's event. Our next event is currently scheduled for April 14th. It's an introduction to cat sparse by Jeff Lewis. If anyone else in the audience would like to do a talk at SF Scala, let me know. I personally quite like the Saturday morning slot, so we get more viewers from Europe and USA. And of course, both William and Chris, open invitation for you to come back whenever you can for more talks. And if you don't want to do a talk, please come back as an attendee.
Yes.
Thank you so much.
Great. Well, if there's no more questions, I guess that's a wrap. That's a wrap for today. And hope to see everyone on the April 14th. Keep in touch. And thanks for attending today. And thanks to our speakers for the talk. And Seth, thanks for joining us on Zoom as well. Appreciate it.
Thank you, Salah, for organizing.
No, pleasure. And I hope
Thank you so much. It's amazing.
And I hope I didn't cough too much to annoy everyone.
No, it was great. And yeah, thanks for having us.
Great. Well, have a great weekend all. See you soon at another event. Take care. Bye all.
Yep. Bye.
Bye.